Good evening, everyone. Welcome to the week 10 of the tutorial session of the course Principles of Communication System 1. So today we are going to discuss some of the questions based on the lectures taken in the week 10th of this course on NPTEL portal. And also we will solve the gate problem related to this week material. So in this week, basically in the lecture it is taught about probability, random variable, central limit theorem, and the probability distribution function. So we will see some of the theory concepts and the questions based on that. So we will take gate question from the gate book and we will solve. So first of all, we will see what is random variable. So basically, random variable is the process of assigning numbers to the outcome of an environment. Like let's suppose we toss a coin. So the sample space S. Let's suppose we toss a two coin. So the sample space can be head head, head tail, tail head, and tail tail. So let's suppose X is the random variable which specifies number of heads. So what will be the number of heads here? 2, 1, 1, 0. So like this only. So we'll write the definition. Random variable specify the process of assigning numbers to the outcome of an experiment. Also, this video will be recorded and uploaded on YouTube. So let me check whether recording is going on or not. Yeah, it's recording. So the example we have taken, this example is basically the random variable X is defining number of heads, possible heads in the experiment of tossing a coin twice. So this is the random variable X is defined such that it is specifying number of possible heads in the experiment of tossing a coin twice. So now we will see what is probability mass function. This was about, and after that will be probability distribution functions as well. So this was all about the random variable. So now take probability mass function. So these concepts of probability are very useful for communication system. So this is denoted as probability of xi is equal to probability of event x is equal to xi. Okay. So now let's take a question. Construct probability mass function for the possible number of heads for the above example only in the experiment of tossing a coin twice. So the sample space is head 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 tail. It can occur tail head or tail tail. So x, the number can be assigned as 2, 1, 1, 0. So now probability of x such that the value is 0 is equal to probability x is equal to 0. So that is 1 by 4. Okay. Probability of x1 is equal to probability of x is equal to 1. So the number of time head is occurring is 1. What is the probability? It is 2 times. So this will be 2 by 4. So that is 1 by 2. And probability of x is equal to 2 is 1 by 4. So now for constructing PMF, we will plot this graph. So this is xi and this is probability of x is equal to xi. So for x is equal to 0, what is the value? 1 by 4. For x is equal to 1, what is the value? 1 by 2. And for x is equal to 2, sorry, the value is 1 by 4 only. So it will go to here. So now this is the probability mass function. So it is used to analyze discrete random variable only. So here write a note point. Probability mass function is used to analyze discrete random variable only. So now let's suppose the next question is find the entropy of the above question. So in this case, we'll write the probability mass function. So for value of xi, we have written the assign the probability. Now entropy hx is equal to summation of I px xi into log 1 by px xi. So we'll put all the value. So px xi is 1 by 4 log 1 divided by 1 by 4 plus 1 by 2 log. Here the base of log is 2 plus 1 by 4 log 2 1 by 4. So this will become 1 by 4 log 2 of 4 plus 1 by 2 log 2 of 2 plus 1 by 4 log 2 of 4. So 1 by 4 into 2 plus 1 by 2 into 1 plus 1 by 4 into 2. This will be 1 plus 1 by 2. That is equal to 3 by 2. So that is 1.5. So the entropy for the above example is 1.5. To find entropy of a random variable, values possible for random variable should not be repeated. Okay. So now we'll move on to the next question. A coin is tossed repeatedly till head appears. So it is tossed until the head appears. That X represent number of tosses required. Find entropy of X. Okay. So there will be different case. We'll analyze all the case. Let's suppose we toss the coin and head appears in the first time. So X represents the number of tosses required. So this will be 1 and probability of occurring head will be 1 by 2. Let's suppose first time it appears tail and then it appears head. So it is 2 and probability of occurring is 1 by 2 into 1 by 2. Now let's suppose tail and head came. So like this it will go on. So the entropy will be summation of pxxi log 2 1 by probability of xi. Okay. So this can be written as 1 by 2 log base 2 into 2 plus 1 by 4 log base 2 4 plus 1 by 8 log base 2 8 and plus so on. So this can be written as half into 1 plus 1 by 4 into 2 plus 1 by 8 into 3 and so on. So actually this is just the summation of n into a to the power of n. Here a is equal to half and n is equal to 1 to infinite. Here you guys substitute. If you substitute n is equal to 1, it will become 1 into half. If you substitute n is equal to 2, it will become 2 into half to the power of 2. That will become 2 into 1 by 4. So now summation of n into a to the power of n is a divided by 1 minus a square. So this will become half 1 minus half of a square. So the final answer will be 2. So in this way we can solve this question. So this is very interesting question. So now moving on to the next question. Or before that see some of the we'll see now what is probability distribution function or commu cumulative distribution function, CDF or PDF. So the next topic is, so we have already seen what is probability mass function. Now we will see probability distribution function, that is also called as the cumulative distribution function. So probability distribution function f of x is given as probability of x such that the value of x is less than small x. CDF specifies probability of random variable x taking the values up to x. So just write this. CDF specifies probability of so random variable x taking the values up to small x. Okay. So now we will take the same example and we will try to understand this concept. Okay. So let's take a question. Construct distribution function. So I'm taking the question now. So it is the same question, that is experiment of tossing a coin twice. And we have to construct the distribution function for this. So first we will give the probability mass function. Three value it can take, 0, 1 and 2. And what will be the probability of that? Xi is equal to 0 will be 1 by 4. This will be 1 by 2 and this will be 1 by 4. Okay. So now this is the probability distribution function is the value like probability up to that value. So let's suppose fx0, what it will be? So when the value is up to 0, this is equal to probability of x less than equal to 0. So this value is 1 by 4. Now fx 0.6. So this is probability x is less than equal to 0.6. So this is again 1 by 4 because up to x is equal to 0.6, the probability is 1 by 4. At x is equal to 1, probability become 1 by 2, so that we will add. So fx1 is equal to probability of x less than equal to 1. So this will be 1 by 4 plus 1 by 2. So what will be answer? 3 by 4. Again, fx 1.5, this is equal to probability of x is less than equal to 1.5. So this is again 3 by 4. When the x value goes to 2, then again this will change. So fx2 is equal to probability of x less than equal to 2. So now all the value of x will come up to x is less than equal to 2. So the probability will be adding of all these three terms. So this will be 1. And again, if you take fx3, again this probability of x less than equal to 3. So again this will be 1. So similarly, fx infinite is equal to probability such that x can take up to the value of infinite. This is equal to 1. Okay. So in this way, we can construct the probability distribution function. So here you can see. Now fx infinite, what it will be? Probability of x less than equal to minus infinite. This is equal to 0. So the value of x is equal to is greater than or equal to 0 and less than equal to 1. So now plot for this on y-axis. We are showing probability distribution function or cumulative distribution function. So at x is equal to 0, it is 1.1 by 4. So this is 1 by 4 and this is 1 by 2 and this is 1. Till x is equal to 1, it is 1 by 4. Suddenly at x is equal to 1, it will jump and it will go up to 3 by 4. So it will jump to 3 by 4 and at x is equal to 2, the value will jump up to 1. Okay. So this is the curve for probability distribution function. So now we will see what is probability density function. The next topic is probability density function. So the probability density function is represented as fx of small x, that is equal to derivative of fx x divided by d of x. Okay. So fx x is equal to minus infinite to x. So the probability density distribution function is just the integration of probability density function. And probability density function is the differentiation of probability distribution function. So just you write a note point. As this is a as density function is the derivative of distribution function. So density function of discrete random variable will give impulses at that value. So just write this note point. Density function of discrete random variable will give impulses. So now let's solve one question. For a continuous random variable x, density function is given below. So the density function is given as, this is minus 10, this is 20, and this value is k. And on y-axis, the density is represented as small fxx. Okay. So we have to find first k, second probability of minus x is greater than equal to minus 10 and less than equal to 10. Third part, we have to find probability of x greater than equal to 10. And fourth part is plot probability distribution function. Okay. Now, so the complete probability will be always 1. So the area under this curve will be 1. So the area is 30 into k is equal to 1. So the value of k is 1 by 30. Now probability such that mine x is greater than equal to minus 10 and less than equal to 10 is the area under this curve. So that is equal to 20 into k. So that is 20 by 30. So that is 2 by 3. Now third, probability of x greater than equal to 10 is 10k, because let's suppose this is the 10. So this value is 10 into k. So that is equal to 10 into 1 by 30. So this is equal to 1 by 3. Okay. So now the fourth part is the interesting one. We have to find probability distribution function that is equal to integration of probability density function. So probability density function is 1 by 30 from the value minus 10 to 20 dx. So this will be 1 by 30 into, sorry, minus 10 to x. It will start from minus 10 and it will go up to x. So 1 by 30 into x, and the value of x will be minus 10 to x. So this is equal to 1 by 30 x plus 10. And for what value of x? When x is greater than equal to minus 10 and less than equal to 20. So now let's plot this curve. So for x less than minus 10, this value is 0. For x is equal to minus 10, again this value is 0. And for x is equal to 0, the value will be 1 by 3. It will just increase. The slope is 1 by 30. It will just increase up to the value of 1 and it will become constant. So this value is 1 by 3 and this value is 1. and here it is 20. Okay, and this is x. So this is the probability distribution function. So now let's take one more example. A continuous random variable x is uniformly distributed in 0 to 10. Plot probability density function and probability distribution function. So for this, first we will plot the probability density function. So it is uniformly distributed in 0 to 10. So if it is uniformly distributed in 0 to 10, so it will be like this. Because the area under curve should be 1. So this will be 1 by 10 and this will be 0 and this will be 10. Okay. Now our probability distribution function is integration of probability density function. So this is equal to 0 to x 1 by 10 dx. So this will be 1 by 10 into x. So this is x by 10. So now the maximum value probability distribution function can take as 1 and this value will occur at 10. Okay. So this is the plot of probability density function and probability distribution function. So okay, we will solve one more question. The next question is very good question. It is a gate question. For a continuous random variable, density function is given by the probability density function. Small f(x) is equal to a e to the power of minus bx. Okay. And here small x is greater than equal to 0 and 0 otherwise. Or it can be also written as a e to the power of minus bx, and unit function you can write because unit function is 1 only for the value of x greater than equal to 0. Else it is 0. In both way we can write this density function. So find the relation between a and b. So when you plot this fxx, so this plot will come like this. Okay. So the total area will be always 1. So we can write integration of probability density function from minus infinite to infinite with respect to dx is equal to 1. So in this case, the value is from 0 to infinite. So this will be 0 to infinite a e to the power of minus bx dx. So this we can write as a by minus b e to the power of minus bx, and value of x is from 0 to infinite. So this is equal to minus a by b e to the power of minus b into infinite will be 0 minus e to the power of 0 is 1. Okay. And this value is equal to 1. So this imply that, or here you can write, this is equal to a by b. So a by b is equal to 1. So it implies that a is equal to b. So understood how to solve such kind of question. So we will see some of the statistical parameters of random variable. The first one is mean. So mean of x can be written as E of x. That is also given as x bar, and that can be written as M1. Okay. So E of x is equal to summation of xi into probability of xi. Okay. For discrete random variable. And for continuous random variable, E of x is equal to integration of minus infinite to infinite x probability density function fxx dx. This is for continuous random variable. And also mean gives us the DC, या average value of random variable, and m1 square is equal to DC power. M1 is equal to DC value. The square of mean is the DC power. Okay. Also the properties of mean, there is three properties. First, mean of a constant term k is equal to k. Okay. Second, mean of k into x is always equal to k into mean of x. And third, mean of x plus minus y is equal to mean of x plus minus mean of y. Okay. Now the next parameter is mean square value. So mean square value of x is given as e of x square, that is equal to x square of mean, and that is also known as m2. So e of x square can be written as summation of xi square, probability of xi, for discrete random variable. E of x square for continuous random variable is minus infinite to infinite x square f x x dx. So this is for continuous random variable. So mxq mean square value gives total power of random variable. So mxq of x is equal to e of x square, and that is also is equal to power of x. So the next is the third parameter is variance. This is very important. So that is denoted as sigma square. So sigma square variance is equal to mean square value of x minus x bar. So this is the deviation of value x from its mean x bar. So that can be given as e of x minus x bar squared. So this can be written as e of x squared, and this x bar is mean. So x bar squared minus 2 into x bar into x. So this can be written as e of x squared plus e of x bar square is mean square minus 2 into e of m1 into x. So e of x squared is m2. This is m1 squared minus 2 into m1 is a constant term, so it will come out e of x. So again, this term is m1. So we can write m2 plus m1 squared minus 2 into m1 into m1. So this will become m2 minus m1 squared. So m2 is e of x squared minus e of x squared. So the variance sigma squared is equal to e of x squared minus e of x squared. So this is very important formula. Just remember this. And also sigma squared is equal to, let's write in the next page only. Sigma squared, this e of x squared is total power minus DC power. So total power minus DC power, what is this? This is equal to AC power. So the next parameter is standard deviation. So this is given as sigma. So standard deviation is simply the square root of variance. So this is equal to square root of variance. So that is equal to square root of AC power. Okay. So this is equal to AC value. So now let's take another example. For a continuous random variable x having density function shown below. The density function of x is given as minus 10 to 10 k f of xx. Okay. So find all possible statistical parameter. Whatever we have studied before, we have to find that. So the first is mean. Mean is equal to E of x. That is given as x of fxx dx from minus infinite to infinite. But here we know that area under the probability density function is equal to 1. So k into 20 is equal to 1. So value of k is equal to 1 by 20. So now we'll substitute, that is equal to, so fxx is 1 by 20. So 1 by 20 will come out and integration of x will be x square by 2. And this value will go from minus 10 to 10. So this is equal to 1 by 20. X square is 100 minus 100 by 2. So this is equal to 0. Okay. So the mean is 0. So also write a note point. If density function is symmetrical along x-axis, mean will be equal to symmetrical point. So here you can see the density function is symmetry to x-axis. The symmetrical point is 0. So the mean value will be 0. Okay. So now coming to the second part of this question, that is mean square value. So that is given as E of x square. So that is equal to x square fxx dx. So this will become 1 by 20 x cube by 3, 10 and minus 10. So when you substitute this value, you will get 1000 plus 1000 divided by 3. So 2000 by 20, how much? 100. So 100 by 3. Now the third parameter, that is variance. So that is sigma square, that is equal to m2 minus m1 square. So here m2 is 100 by 3, m1 is 0 square. So that is equal to 100 by 3. The fourth parameter is standard deviation, that is square root of sigma square. So that is equal to square root of 100 by 3. So it will be 10 by root 3. Now we will see Gaussian density function. So Gaussian density function is given as 1 by under root of 2 pi sigma squared e to the power of minus x minus a square divided by 2 sigma square. And the value of x is from minus infinite to plus infinite. Okay. So the Gaussian value will be symmetrical about the value a from the x-axis. So m1 mean is equal to x of fxx dx, but this curve is symmetrical from the x-axis at value a. So this will be the answer will be a. The second is m2, that is mean square value. So this will be x square fxx dx. So this is equal to sigma squared plus a square. And third is variance, that is equal to m2 minus m1 square. So this is equal to sigma square. So now let's take an example. F of xx is given as 1 by 3 root of 2 pi e to the power of minus x minus 4 square divided by 80. So what will be the value now here? So a is equal to 4. So for this example, let's take then a is equal to 4. This is a. Under root 2 pi sigma square is equal to 3 into root 2 pi. So sigma is equal to 3 and sigma square is equal to 9. Okay. So m1 is equal to 4, m2 is equal to sigma square plus a square, that is equal to 9 plus 1625, and sigma square is equal to 9 and sigma is equal to 3. So these are the statistical parameter for the given question. Now let's suppose let a is equal to 0. So this is equal to normal density function. So this have 0 mean and sigma square as the variance. So this is written as 1 by root under 2 pi sigma square e to the power of minus x squared by 2 sigma squared. So the plot of this is, it will be symmetric from the x is equal to 0. Okay. So this was all about Gaussian density function. So similarly, we can see for uniform density function. So for uniform density function, let's suppose function is defined from A to B uniformly. So this value will be A plus B by 2. And this is the density function. So value of K will be here 1 by B minus A. Okay. For the value of X lying between A to B, and K is equal to 0 for otherwise. Mean is equal to A plus B by 2, or also you can find M1, that is equal to X of fxx dx from A to B. So this will be X, f of x will be 1 by B minus A, and this will be x squared by 2 B by A, B and A. So this value will be 1 by B minus A, B square minus A square by 2. So this will be B plus A by 2. Okay. And MSQ will be A to B x squared fxx. So this will be 1 by B minus A x cube by 3. So this will be B cube minus A cube divided by B minus A ka cube. So MSQ will be B square plus AB plus A square by 3. Okay. Now variance, sigma square is equal to M2 minus M1 square. So this will be equal to B square plus AB plus A square by 3 minus A square plus B square plus 2AB by 4. So sigma square, when you find, you will get A minus B ka whole square divided by 12. So this is also is equal to length by 12. Okay. So today we'll stop the lecture here only, and this video is recorded and will be uploaded on YouTube, and the link will be shared in NPTEL portal, and also the PDF of today's lecture will be uploaded on the Drive link, and the link will be shared. So thank you everyone for attending today's lecture. We'll meet in the week 11th lecture on the next Saturday 3 to 5 p.m. Thank you.